Seems like every time I look at this power supply I discover another problem. So while I was setting up to make another video on this power supply and just going through a few basic bits and pieces, I've noticed that the power supply has another quite worrying feature. So what happens is that this is a very basic setup. I've just gone back to basics just so I can actually determine if the problem is caused by the power supply or some of the other equipment that I've got connected to it. So what I have is the power supply. I've got the two supplied power cables, and I've got a 4 ohm 100 watt resistor. And that's just for clarity. Let's just actually measure that. So 4.2 ohms. Okay, I have put a bit of tape. I'm just using this as a heatsink, this metal plate. And I have put some tape on there so I don't create any short circuits. Right, so what I've found, so one viewer asked me to make a video of the power supply starting up and shutting down with the current plots. Now the video that I actually produced on that, the viewer said that he was actually hoping that I would literally just connect the power to the resistor or to the load with the output enabled. So I was just in the process of setting up, and I just did a trial run. So what I was doing was, so I'll demonstrate. So the power supply has got a set for an output voltage of 5 volts and a current limit of 400 milliamps, and this is a 4 ohm resistor. So as you can see, the output is currently on. And if I just connect the load, I haven't got the scope connected up at the moment, I just want to eliminate that from the process. So you can see that the output wattage is 0.65 of a watt, and the voltage drops down to 1.62 volts with an output current of 400 milliamps. Lovely. So I can disconnect that, goes to 0, reconnect it. Okay, lovely. If you actually do that, so if you actually do that twice in quite fast succession, then what happens is, okay, so the output switches off by itself. You get the error REP. Now I'm not sure exactly what that means, but I assume that is it's obviously a protection. Let's just have a look in the manual for a second. Okay, so I've had a search through the manual for the word REP. And the only instances of that are with relation to repair and replace and that kind of thing. There's nothing indicating what that fault actually means. So if we come to the parameters actually of the device itself, it can only be one of two faults. It's either the output reverse injection protection or the input reverse connection protection. So I would say it's one of those two. I don't see how it can be the input because that's internal to the device. So I would imagine it's saying that the output, there's a reverse injection protection. So in other words, the power supply is determining that you're actually injecting some kind of voltage or current into the power supply. That is what I think is happening. So let's actually just connect the scope up and have a look to see what's actually happening on the output. So I'll just connect the scope directly across the resistor. So let's connect the power to the resistor and boom. So yeah, let's do that again. So as we can see, if I connect it relatively slowly, we do get a little bit of overshoot. I think it's just a bad connection. This isn't really the best way to do this, but this is what I've been asked to do in the video. So okay, so if I do it slowly, get a bit of overshoot. So we're on 1 volt per division, so that's approximately 1 volt of overshoot. And that could just be the reaction to the connection that's being made. But then if I do it, let's wait for the trace to finish. So I do it relatively quickly. Okay, it's just gone straight into REP. The output has been disabled. And now pressing the run stop button has caused the scope to crash again. So it's making a continuous tone and is unresponsive again. So let's power off. Power back on. Turn the output on. Okay, connect, disconnect. Let's do it rapid succession. Boom, rep. So it's quite consistent. Let's see if we can actually look at the actual voltage. Yeah, so we can see on that trace there. Let's move that down to the bottom, see if we can see how many volts that was. Let's reset the power supply, and again it's crashed. Oh dear, this thing. Reset. Output on. Okay, so there wasn't a massive voltage spike that time. Nor that time. And again it's crashed. Reset. Okay, output on. Power, the fan has just started again. So connect the power. So there's a bit of overshoot there, nothing major. Now if we go relatively slowly, presumably giving it time to discharge, for the internal caps to discharge, it appears to be okay. Do 2 in quick succession and it goes into the REP fault, shuts down the output. If we do that again, well, we had a big spike that time. Well, let's just look at that in a moment. Yeah, let's reset. So the spike that time has gone all the way off the top. So we're on we're on half a volt per division. So that's 1, 2, 3, 4, 5, 6, 7, 8. So it's 8 divisions, which is 4 volts. Let's go to 1 volt per division. Yep, so just 2 in quick succession is enough for it to turn the output off with a fault, REP. I just want to try and catch one of those big spikes again. There. Stop. Okay, that is. So that is 1, 2, 3. That's about 3.5 divisions. So that's about 3.5 volts output. So there you have it. Another day, another problem with the FNIRSI IPS 3608. I'm going to continue with the video that I was originally going to make today, and then we'll see what happens with that. So if you enjoyed this video, please subscribe to the channel, give the video a thumbs up, all that kind of stuff, and I will see you in the next